Welcome to this third video in this deep dive series that I'm doing on vSphere with Tanzu. Now in this third video, we're going to be looking at enabling the cluster that we created in the first and second videos for workload management. Now, if you want to find out how I set up all this infrastructure, really deep dive into all the prerequisites, all the networking, the network routing, the cluster itself, the cluster configuration. That was covered in great detail in the first two videos, so I recommend that if you want to find out about that, you go and watch those. If you want to just skip ahead and really understand the goodness, the value add of vSphere with Tanzu, where you actually get to deploy upstream Kubernetes clusters and play with them, skip ahead to the next video because that's where we'll be doing that. So this video is focusing on how we enable an existing vSphere cluster for workload management, and we'll be covering how to set up the HAProxy load balancer as well as part of this video. Let me remind you where we left off. We have this nested vSphere cluster that has all the prerequisites satisfied, and that has three key networks: a management network, a front-end network, and a workload network. And all of these IPs we used in the setup previously. Well, pretty much all of them. There's a couple that we haven't used yet, but we're almost there. If you want to know more detail about this, go and watch that first video. But the TLDR is that all the physical infrastructure is on the management network. The Kubernetes nodes will be allocated onto this workload network that's isolated, and the front-end network will be presenting virtual IPs that allow clients to connect to the Kubernetes control plane and to access Kubernetes services. So the two tasks we're going to focus on in this video is deploying the load balancer that we need in order to provide those virtual IPs and the load balancing capability on that front-end network. And the second task we're going to do once we have that is actually enabling workload management on this cluster. Now, I'm going to start referring to our documentation when we do this, which is here. Now, you'll see that I got to this from VMware vSphere product documentation, vSphere with Tanzu configuration and management, prerequisites for enabling workload management, and we're looking at the requirements and topologies for setting up a supervisor cluster with vSphere networking. What is a supervisor cluster? Well, a supervisor cluster is the Kubernetes cluster that we stand up inside of a vSphere cluster that is really part of the vSphere fabric of that cluster. And the whole point of that Kubernetes cluster that we set up is it's there to bootstrap other Kubernetes clusters. It provides all of the, it really enables vSphere to talk Kubernetes. I know that's kind of a crass way of saying it, but it's basically, it knits together things like, for example, SSO, right? vSphere SSO just works seamlessly with the Tanzu Kubernetes clusters, the upstream Kubernetes. And the way that that works is via this supervisor cluster that runs in the vSphere cluster. Another example is the way that we orchestrate the lifecycle management of the virtual machines that are the Tanzu Kubernetes cluster nodes is through Kubernetes controllers that run in that supervisor cluster. So we have Kubernetes managing Kubernetes, and that's the way that this works. So that supervisor cluster, or I guess you could call it a bootstrap cluster or a management cluster. The supervisor cluster is the piece that's the sort of core management cluster, and that's really where we want to aim to get by the end of this video. Okay, so this page goes through a bunch of prerequisites, and it basically talks about like what we need to do. Now we have pretty much everything set up that we already need. It does talk about, there's some really good pictures in here that talk about different topologies that you can set up. This topology is where you have just a management network and a single workload network that functions as both the workload network and the front-end network. This one is where you have multiple different workload networks, each of which are isolated from each other, which means that in this scenario, the workload network that the supervisor cluster nodes get an IP on is actually isolated from the workload networks of the Kubernetes clusters themselves. And you make sure that they're L3 routable to each other. Now in my setup, we've gone for this one where we only have one workload network that everything is sharing. But we do also have that separate front-end network. Now this one is just showing the same thing, but with multiple workload networks with different Kubernetes clusters inside of them. And then this one here is demonstrating, here you go, HAProxy configuration with 3 virtual NICs. And this is what we're going to be doing. The 3 NICs are the management interface, the workload interface, which corresponds to the, as I say, these Kubernetes cluster nodes, and the front-end interface, which is where HAProxy is going to be publishing its virtual IPs. And that is where the DevOps user accesses the services. I'm not going to go over, this is very, very useful in understanding some of the requirements. So, for example, the 64 gigabyte per host requirement and the 8 CPUs that we configured our hosts with. I'm not going to read through this page because I'd much rather just focus on what we're actually going to do, but it's worth noting that everything that I'm doing is described here in this page. Now, what is important is this link here. Now, this link takes you to the a very, very simple knowledge base. It tells you how to go and download and install our HAProxy appliance. So if we click on that, interesting, remind me later. Okay, so this is HAProxy, VMware HAProxy. Now from here you can download the latest version of our HAProxy appliance, which in this particular case is 0.1.8. So I'm actually going to do that. I'm going to download that to my downloads folder, and I will upload that to the content library, and I will join you again when that's done. So HAProxy is now uploaded to the content library, and I should be able to find it in here. There it is. Let's deploy it, new VM from this template, HAProxy 0.1.8. We'll deploy it into our data center. We'll deploy it to the workload cluster. Now, the reason we're doing that is because it needs to connect to the port groups that our workload assets are connecting to. That's not to say that you couldn't make it work in the Bootstrap cluster, but for the sake of confusion, I think it makes sense to keep it in the same cluster as the workload assets. Now, this is an important choice. This is the 2-NIC, 3-NIC choice that we saw earlier on in our system requirements. If you remember, there's these various 2-NIC configurations, and then there's a 3-NIC configuration. The 2-NIC configuration is where you have a management network and you have the workload network and the front-end network combined into one. This configuration with 3 NICs has a management network, a workload network, and a separate front-end network, which is the way that we've configured our fabric. So that's what we're going to choose. Okay, so now I'm going to pick the data store. I'm picking the physical vSAN data store. Thank you, HCI Mesh. Now I have to pick the port groups that this appliance is going to go on. Now, workload and front end are easy. Obviously, it's going to be workload and front end. But I do want to take a moment to explain what we mean here by a management network, because management is a very overloaded word, and it has a specific meaning when it comes to HAProxy. So HAProxy has a process that runs inside of it called the data plane API, through which HAProxy is remotely programmed by the supervisor cluster. Now, the supervisor cluster needs to be able to authenticate to this management endpoint, and it needs to be able to reach the management endpoint. It needs to be able to route to it. Now, in this particular lab setup, I can pick this this nested VM network because the VM network and the management network are basically the same L2 network. There's actually no difference between them. It's really just a basically just nomenclature in this lab setup, but it's worth understanding and noting why that is. I hope that was clear. Actually, when later on, we're going to actually test that you can get to this management endpoint on this appliance from the right place. And so you'll be able to see what I mean, hopefully, a little bit more clearly when you see me do that test. Okay, so password. I'm going to put my password in here. And I always like to double check that I've got it right so that I didn't fat finger it twice, because that's always annoying. Okay, we want to permit root login because we're going to want to be able to log into this appliance to get a certificate out of it later. Speaking of which, you can supply your own certificate authority and key here, but I don't have one. I'm just going to let the appliance generate it for me. Now, that certificate authority and the key is used for authentication of the supervisor to this management portal that I talked about on the HAProxy so that it can be programmed. So what we'll do is we'll have those certificates be generated when the appliance is created, and then we'll copy the certificate authority out and tell vSphere what it is so that it can make that connection and be authenticated. So that's good. We've done that. Hostname I'm going to leave as the default. The DNS is 192.168.1.1, which is what all my networks route to. Okay, so this is now the important part, management IP. So this is the IP this appliance will have on the network that we've selected for the HAProxy management portal. So that means it's going to need to be an IP on this network, and I'm going to pick 180 for that. So that's the HAProxy. Okay. So 192.168.1.180, and I'm in this setup, rather than using a specific net mask, a subnet mask, you just use the CIDR notation. So /24 is equivalent of 255.255.255.0. That's what that is. It's kind of confusing because sometimes CIDR notation is used to denote a range of IP addresses, but in this particular case, that's not what it's denoting. So the gateway for management is the same as that. Good, we're done. So workload IP. So we need this appliance needs an IP on the workload network. And I've already picked one out. That's 5.5. So it's going to be 192.168.10.5. You remember the workload network is VLAN 10, so it's going to have subnet 10. And again, /24. The gateway is going to be 192.168.10.1, and that is the gateway that we set up in the previous video. The front-end IP, I think, is going to be 20.5. I'll verify that, but I'm pretty sure that's correct. 20.5, yes. And then the workload, the front-end gateway is going to be 20.1. Now again, this is a separate VLAN. This is VLAN 20, and that's why 20 is in this subnet. So these are the static IPs that this appliance is going to get for its 3 NICs on the 3 different networks that it's going to be talking to. And of course, traffic is coming in on this front-end network. It's then basically being routed, load balanced to this workload network. And the whole thing is being configured and programmed via this management network. So, load balancing. Now, the load balancing IP ranges, what this means is HAProxy has the ability to load balance multiple IPs. Now, in typical configuration, the way that people stand up HAProxy is they'll use a single IP and they'll use multiple ports, for potentially for different services, or they'll use multiple URL patterns. There's various different ways of routing traffic to different places. But typically, it will use a single IP address. And there may be multiple instances that have a floating IP that can map between them. And actually, when you go and look at the online tutorials, that's pretty much all you see. You see HAProxy has one IP, and there's a floating IP, and the floating IP maps to the particular HAProxy instance that's currently active. This is different. This is different in that it uses a capability of Linux called AnyIP, which allows Linux to pretend to be any number of IPs you want within a range on a network. And then we've configured HAProxy to be able to respond to any of those IPs. Now, it's a pretty clever mechanism because, as I say, it allows you to, from a single load balancer, serve any number of IPs through using the same appliance. The downside to this, though, is that the moment that HAProxy starts up, it will respond to a ping on every single IP in this range. That's the way that any IP works. So what that means is that you've effectively reserved every IP in this range for load balance services, and you certainly don't want DHCP or anything else to be trying to use IPs in this range because they are effectively reserved. And we'll see once this is deployed what that looks like. So what IPs am I going to use? Well, given that I want these virtual IPs to be created on the front-end network, because these are going to be the IPs that clients use to connect to my Kubernetes services, I'm going to use a range 128 to 254, which is this range here, which is 2128/25. Now this /25 is an example of a CIDR notation being used to express a range of IPs, rather than the CIDR notation being used to express a subnet, which is what we saw earlier. So this is these basically, when we start this appliance up, we should be able to ping 2128, 2129, 2130, all of the IPs in this range. Now, remember I mentioned earlier on the management of HAProxy is done via the management network and this service that it exposes. This is the port that it exposes that service on. Now, obviously, you need to make sure that this is going to be compatible with whatever firewalls you might have. The default is 5556, so we'll stick with that. And this is the HAProxy user ID and password is also part of the authentication that Supervisor cluster uses to talk to HAProxy in order to program it. So I'm going to use HAProxy user ID, and I'm going to do my password. And again, I want to make absolutely sure that's correct. It is correct. All right. So hopefully all this made sense. It will make more sense once we get this up and running and you see how it configures. So let's watch this boot. Oh, it's going to deploy it first, and then we have to power it on. Okay, HAProxy is booted, and we can look at the IP addresses that it has, and we can double check those against what we thought we had. Now remember, it has these three interfaces. The management IP is 1.180, the workload IP is 10.5, and the front-end IP is 20.5. So that looks good. That looks exactly how we want it to look. Now, there's no need to reconfigure the memory and CPU, at least initially. We've tested this up to pretty high throughput, and 2 CPUs and 4 gig of memory actually covers you pretty well up to, I don't remember the exact number, but it's adequate, certainly adequate for moderate loads. So the first thing we're going to do is we're going to get onto this HAProxy appliance, and we're going to make sure that everything works as we expect it to. So 92.168.1180. Yes. Aha, got my password wrong. All right, so let's try that again. There we go. So let's see what we have. All right, so we have, you'll see here's the data plane API that I talked about. This is the management portal that's used to configure HAProxy by the Supervisor cluster. Now, if we go to, I'm going to show you a couple of important and interesting files in here. If we go to etc HAProxy and have a little look, you'll see some configuration files. If we cat haproxy.config, this is where you'll see all the configuration appear when it's programmed by the supervisor cluster. So the front ends and the back ends, everything will be in here. So if you're unsure about whether HAProxy is working or whether it's configured correctly, you can come and have a look in here, and that will show you. Another very useful thing that we need to look at in here is the certificate authority that was generated for us. We're going to need that in the enablement step a little bit later, so that's good. Now if we look at our network config, you'll see we have three interfaces, actually usefully labeled front-end management and workload, and that all looks correct. Now remember I mentioned that the NEIP range is everything in that range is pingable. So if we remember the range that I talked about, which is the VIP range, the VIP range, which is the virtual IPs, let's try pinging 192.168.20.128. Yep, so I can ping that 20.129, I can ping that 20.130. So this appliance will respond to any IP in that range as if there was something backing it. Now there's actually, there's nothing, there's no services actually running that are serving anything on these IPs, but the way that NEIP works is it basically reserves all those IPs for you. So that's good, that's working. Now the next thing I want to do is just verify that we can reach the management portal from vSphere. So what I'm going to do is I'm actually going to create a new tab here, and I'm going to log into my vSphere vCenter server. And I'm assuming that, since I'm a vSphere admin right now setting all this up, that I know how to do this, and that I might be used to doing this. I don't know. All right, so let's get a shell. Okay, so I want to be able to make sure that I can at least ping the management IP from vCenter. 68.1.180, and I can. Okay, that's good. So what that means is that the management IP of the HAProxy appliance is reachable from the vCenter server, which should be enough to demonstrate that we can actually talk to HAProxy and that's going to work just fine. Now there is another command that you can put in there. Okay, so I can curl, if I can curl the endpoint, and it's 180. If I can curl the endpoint on that port with this URL, without the certificates, but with the user ID that I specified, it's going to ask me for the password. Now the password is the one that I configured in the appliance, and that's good. What that tells me is that I can get to the management endpoint, that I can actually pull data from the management endpoint with the username and the password that I configured within the appliance, which means that when we enable workload management, if we put the exact same configuration parameters in, such as the username and the password, the IP address, and the port, everything should just work fine. So that's a worthwhile check if you can do it, just to make sure that everything makes sense. So it seems like HAProxy is happy that everything has come up correctly, and we'll leave that open because, as I say, we're going to need that certificate in a moment. So let's go back to our browser, go back to vCenter. All right, HAProxy is running, and we're going to leave that alone for a moment. So the next thing I'm going to do is enable workload management on this cluster. Okay, so the next thing I'm going to do is enable workload management on this cluster. That will set up the supervisor control plane nodes and get everything configured and set up so that we can start to deploy our upstream Kubernetes clusters. So one check that I didn't do actually in the HAProxy that I'll just quickly do, I just want to make sure that I can actually ping the workload and front-end gateways. Again, a worthwhile check. I can, just to make sure that, I mean, this is belt and braces because we did check that the networks were working correctly. But yeah, that's good. It can see both of those gateways. So that is great. All right, now let's go back to here. Let's focus on enabling this cluster for workload management. So you go and select the workload management tab. Now, when you first do this, it asks you to put in your details to get to this screen. I've already done that, so I'm here. And it gives you a 60-day trial period, which this is the trial license that I'm using right here. Okay, so what is it saying? It's basically saying, okay, this works with standard vSphere networks, which is good. That's what we set up. You must enable vSphere HA and DRS, which we have done. You must create storage policies that will determine the data store placement. Let's just do that right now. So if we go to policy management, policies and profiles, let's create a storage policy for our Kubernetes. And you'll see why this is useful later. So let's call this Kate's default storage. And we're going to enable a tag-based placement rule. Now, I already created a tag previously. Use storage tagged with physical vSAN. So this is basically this default Kubernetes default storage policy will ensure that anything that selects it will provision to our physical vSAN cluster. So that's any persistent volumes that are created, the nodes, the upstream Kubernetes nodes that are created. We're going to be using this policy quite a bit. So we've created that policy, and let's go back to our workflow. All right, load balancer. We have configured our load balancer, so that's good. And then you must create a content library on the selected vCenter server system. Right, let's do that. Now, this content library is a remote content library. Now, the one that we created previously is a local one that I'm just uploading things to. A remote one, however, allows us to, it's like a kind of an app store kind of thing. So we can present content on a remote URL that your vSphere cluster can download in the background. So I need to make sure that I have the correct path, and it is this one. It is this one. That is the subscription URL. Now I'm going to download content when needed. I don't need to download everything because what this content library has in it, and I'm going to put it on the. No, I'm going to put it on my iSCSI because that's where I put my other content libraries. What this content library has in it is basically a bunch of different versions of Kubernetes. And this is all upstream Kubernetes. You'll see if we click on this, there's 8 versions in there right now, 16.8, 17.7, 16.12, 17.8. When you stand up your upstream Kubernetes, you can pick from any of these versions that are available in this content library. Back to workload management. All right, it looks like we have read this page and we've satisfied the requirements, so let's get started. So it's giving us a couple warnings up here, and let's read what it says. You must configure an HAProxy instance. Well, we've done that, so that's good. And there's no NSXT detected for the selected vCenter, but you can proceed with the vCenter server network option below. Good. Both of those things are fine. So the vCenter server that we're going to be using is this one, which is the only option. And we're going to be using standard vSphere networking. So next. Now, the only cluster that's compatible currently with workload management is our workload cluster, and that's because it has all of the necessary configuration applied. So we'll select it. Now, if your cluster doesn't appear in that list, it's probably one of those prerequisites like high availability, DRS, something like that that's just not been configured in the cluster. So go back and see if you can figure out what that is. Now this is the t-shirt sizing for the control plane nodes, for the supervisor cluster control plane nodes. Now, when you enable workload management, 3 supervisor cluster nodes are deployed to the vSphere cluster, and those 3 nodes run, as I said, all of the internal control loops and integrations that enables all of the cool stuff with Tanzu. Now, I'm going to pick the tiny size because given the size of my cluster, that seems like the only rational thing to do. The storage for my control plane VMs, I'm going to use my new Kate's default storage policy. Now I don't need to use that here. I could use any storage policy, but you know, since I've defined it, I might as well. This is Kubernetes, and it's going to go where I want it to go. Okay, so load balancer. Now this is where we get to tell vSphere everything that we configured HAProxy with, so that it can make that connection to the management plane. So we'll just give it a name, which doesn't really matter, and select the type. Now remember, the data plane IP address is the address on the management network with the port that we specified. So 192.168.1.80, whoops, 1.180.5556. Now that, if you recall, when we were on vCenter and we reached out to that management port, that was the IP that we used. So that's why we're putting this IP import in there. The username and password is HAProxy, and make sure that I got that right. Yes. Now again, remember, that's the username and password that I used when we accessed that control plane when we did the test in vSphere. Now the IP address ranges for the virtual servers. Now remember, when we configured HAProxy, it's basically responding to any IP within a particular range. That's this range right here. Now, this is asking for the range, not with a CIDR notation, just as an actual range. Now, there is a reason for that. It means that it won't, we do our own IP address management, and if you want to make sure that it doesn't allocate the first IP in a range, or it doesn't allocate the last IP in a range, it's much easier to express that with a range rather than with CIDR notation. So that's why that's what it's requiring. So we're going to do 192.168.20.128 to 192.168.20.254. I believe that's correct. 128 to 254. Okay. Now the certificate authority is the certificate authority that we got out of HAProxy earlier, which we just paste in. And again, that's so that vSphere can make a secure connection to the HAProxy management endpoint. Okay, so management network. Now this needs to be the vSphere management network. So on my nested distributed switch, I have a management network, and I'm going to select that. The supervisor nodes and vSphere are basically privileged to each other. Nothing else is allowed on those supervisor management nodes. In fact, you can't even get onto those supervisor nodes. So given that privileged relationship, it makes sense that they have access to the management network. Starting IP address. Okay, so this is going to be the first IP address of 5 that are required for the supervisor nodes on the management network. And it'll tell you that if you click on this, it says the first IP in a range of 5 IPs for the supervisor control plane VMs. So let's go back here. Let's give it 181. Let's give it 181. So 181 to 185, 1, 2, 3, 4, 5 inclusive is going to be the supervisor control plane, or just supervisor nodes. We'll say supervisor nodes. So that'll be 192.168.1.181. Okay. Subnet mask. Gateway 192.168.1.1. DNS server is going to be the same. No such domains. NTP server is going to be pool.ntp.org. Okay. And if you want to view a pretty picture that shows you, kind of helps you understand the network topology, they present that there. So let's just double check this. We've given ourselves 181 to 185 for the IP addresses of the supervisor nodes. Subnet mask, gateway, DNS server, they're all correct. Yep, that looks good. So now the workload network. Now, the workload network configuration needs a little bit of explaining. Now remember that the supervisor cluster is Kubernetes. And given that it's Kubernetes, it needs to be configured with some of these Kubernetes configuration options that you would configure any Kubernetes cluster with. And when you configure a Kubernetes cluster, typically it will ask you for a CIDR range for Kubernetes services and a CIDR range for pods. So the CIDR range for Kubernetes services in this particular case is, you can pick anything that you want. In this particular case, we can just go with the default, 1096.0024 is fine. /24 is quite a small range for Kubernetes services. It'll basically give you 254 odd IP addresses. If you wanted more than that, you could select a /16 or a /12 or /20. It's entirely up to you. But the supervisor cluster isn't going to be creating a ton of services, so /24 actually feels like a perfectly reasonable default to take. Now, DNS servers. I'm going to do 192.168.1.1 because that is my only DNS server in the system. Okay, so now we're going to assign a workload network, which is the network that when we deploy an upstream Kubernetes cluster, that's the network those nodes are going to be deployed to. So we'll call it network 1, that's fine. Now remember, there's a couple of different configurations you can have for the workload network. If you recall this diagram here, you can either have the supervisor workload network be isolated from the Kubernetes cluster workload networks. In our case, they're not isolated. We're going to just use the same network for both. But if you're going to use multiple, you'd use this toggle here to set the primary network or set the other networks. So let's pick our port group. Now this is a little confusing. The way this is, it doesn't scroll, so it makes you think that it's not there. But actually, you have to go left and right for some reason. I'm going to pick the workload port group, which is the port group that we set up and tested specifically for our workload assets. What are our workload assets? Well, as I mentioned, when we stand up a Kubernetes cluster, the nodes are going to get IPs on this workload network. So what is the gateway? The gateway is the gateway we configured in video 1, which we've been testing with, and it's 10.1. The subnet is the standard subnet. Now, what is the IP address ranges? Well, these are the IPs that those Kubernetes nodes are going to be assigned, right? So any IP within this particular range. So if we go back and look at our list, you see here 10 to 253 are our workload IPs. I'll change that to 253. We're good. Those basically, that's the range out of which vSphere can assign IPs for those upstream Kubernetes nodes. So that is our one workload network, and we've configured that. All we need to do now is tell it what content library is the Tanzu content library. So we'll OK that. And now we just review and confirm. Now let's just go back and just double check that we got everything right. So we're using the workload cluster, we're using tiny control plane, we're using the default storage policy, which will put it onto a physical vSAN. Our data plane IP, which is our HAProxy management IP, is correct. The certificate that we pasted in. Now this is the range, the virtual IP range that HAProxy is going to be allocating from. And here the slash is actually the number of IPs, which is kind of confusing. It's not a subnet, it's just the number of IPs, so 126. Starting IP address of our supervisor control plane nodes is 181. And as I say, you'll see when it comes up, each supervisor node gets an IP on the management network and an IP on the workload network. So you'll see the first one that comes up will have like 181 actually 181 is going to be a floating IP that gets to point to whichever is considered the master. But it'll come up with 182 on one interface, and it'll come up with most likely 10.10 on the other interface. So this all looks correct, and let's finish that. And I'm going to go to bed because it's very late and I need some sleep, and I will come back to this tomorrow, and hopefully I'll wake up to a beautifully fully configured and error-free cluster.